All right, so today you guys are going to learn about independent and dependent events. So here's the gist. What is an independent event? An independent event is when one event does not affect the outcome of another event. So for example, if you have a coin and you toss it twice, the first toss has no effect on the second toss. On the other hand, we have a dependent event. And in this case, the outcome of one event affects the outcome of the other event. So for example, if you pick a card from a deck, do not replace it and go to pick another card. That's a dependent event because the probability of your second event is affected by that first event because you're going to have one less card in the deck. So let's do some examples together. You guys will follow along on your notes. And I'm going to warn you, if you hear weird tapping, it's because of the pen. So here we go. Two spinners numbered 0 through 9 are spun. What is the probability that both spinners will show a number greater than 6? So I'm going to go back. We have two spinners. They're numbered 0 through 9. We are looking for the probability that both spinners will show a number greater than 6. So just like we've been doing, it's going to be helpful for you to have categories. So I'm going to list a category as spinner 1 and spinner 2. So on spinner 1, I'm looking for the probability that it has a number bigger than 6. So the numbers that are bigger than 6 on that spinner would be 7, 8, and 9. So that means that there are 3 numbers on there that are bigger than 6, and there's a total of 10 numbers. So the probability of getting a number bigger than 6 is going to be 3 out of 10. Now, on spinner 2, it also is numbered from 0 to 9. So 7, 8, and 9 are also going to be greater than 6. So the probability of getting a number greater than 6 on spinner 2 is also going to be 3 out of 10. And just like we've been doing, we're going to be multiplying these together. You can try to cross cancel now. There's nothing to cross cancel. So multiply your numerator, multiply your denominator, and then you get 9 over 100. So this is an example of an independent event because whatever you get on spinner 1 has no effect on what you get on spinner 2. Okay, so let's go to number 2. So a red number cube and a white number cube are rolled. Both cubes are numbered from 1 to 6. What is the probability of not rolling a 3 on the red number cube and rolling the number 3 or less on the white number cube? So this is a lot of information, so I'm going to go back. We have a red number cube and a white number cube, and they're both numbered from 1 to 6. We want to know the probability of not rolling a 3 on the red and rolling the number 3 or less on the white. Okay, so I'm going to label red, and I'm going to label white. And on that red number cube, we want the probability of not getting a 3. And on the white number cube, we want the probability of getting 3. Sorry, that came out weird. We want the probability of getting 3 or less. So on the red number cube, or on any number cube, how many numbers on there are not the number 3? That would be 5 out of 6. And then on the white number cube, we're looking for the numbers that are 3 or less. So that would be 3, 2, or 1. So that would be 3 out of the 6. So you guys can multiply those together. Before you multiply though, we can cross cancel. I can reduce 3 and 6. We can reduce that to 1/2. There's nothing else from here we can cross cancel. So we multiply across the top, multiply across the bottom, and we end up with 5/12. And so again, this is an example of an independent event because whatever you get on that red number cube is not going to affect what you get on that white number cube. Okay, number 3. There are 4 red, 8 yellow, and 6 blue socks mixed up in a drawer. Once a sock is selected, it is not replaced. Find the probability of reaching into the drawer without looking and choosing 2 blue socks. Okay, so let's go back. We have 4 red, 8 yellow, and 6 blue. Once a sock is selected, it's not replaced. That means you reach in, take it out, and you leave it out. You don't put it back. We need to find the probability of choosing 2 blue socks. So for our categories, we're going to have our first pick and we're going to have our second pick. And for our first pick, we want the probability of getting blue. And for the second pick, we also want the probability of getting blue. So when you first reach into that sock drawer, there are 6 blue socks, and there's a total of 18 socks. So you're going to assume that when you reach in there that you get that blue sock. You're always going to assume that what you want to have happen will happen. So there were 6 socks, you took one out, and then now there's only 5 blue socks left. And since you took a sock out, there's not a total of 18 socks, there's only 17 socks. So before I solve, I can cross cancel. I can reduce 6 and 18. I can divide each of those by 6, so that becomes 1/3. There's nothing else to cross cancel, so I multiply my numerators and my denominators, and that's my probability. So this is an example of a dependent event because what happened first affected what happened second. Our probabilities when we reached in for that second sock changed because of what happened first. And just a heads up, whenever it tells you that something is not replaced, that's always an example of a dependent event. So what I want you guys to do next is go to your math book and go to page 777. And I want you to pause this video and try A, and then when you're done with A, replay it so that you can see if you did it correctly. Okay, so for A, what you guys should have done is we are rolling 2 number cubes. So here's my first number cube, and here is my second. And we want to know the probability of rolling 2 or 4 on the first number cube. So that means there's 2 out of 6. And then on the second number cube, we are rolling a 5. So that would be 1 out of 6. And I'm going to go ahead and cross cancel. I can reduce 2 6 to 1/3. And there's nothing else I can cross cancel right now. So we end up with 1/18. I want you to turn the page. And then on the next page, do B and C. So go ahead and pause this right now. Do B and C. And these questions you have to look up above at number 3. So do B and C, pause it, and then when you're done, unpause it so you can see how you did. Okay, so for B, you want the probability that you are going to choose 2 bananas. So you have your first pick and your second pick. So for your first pick, when you reach in there, there are 7 bananas. And there are a total of 16 pieces of fruit. So you're going to pick that banana and you're going to keep it out. And then when you go to get your second banana, there's not 7 in there. There's 6. And there's not 16 pieces of fruit. There's 15. I am going to cross cancel. I can cross cancel 6 and 15. I can divide each of those by 3. So this becomes 2 and this becomes 5. Then I can cross cancel again. I can cross cancel the 2 and the 16. I can divide each of those by 2. So this is 1, this is 8. And then that would give us a total probability of 7/40. So that's what you should have gotten for B. And then for C, I'm going to work over on the right side. We have our first pick and our second pick. So for your first pick, the probability that you get orange is 4 out of 16. And then you're going to keep that orange out. You go in and you choose apples. So there's 5 apples to choose from. But now there's not 16 pieces of fruit, there's only 15. Again, I'm going to cross cancel this, so this becomes 1/3 because I could divide each of those by 5. I can also reduce 4/16. I can divide each of those by 4. And then multiply sideways, and you should get 1/12. So C is 1/12. Okay, then what I want you guys to do next is go down to guided practice. You're going to do 1, 2, and 3. So pause this video, do 1, 2, and 3. When you're done, unpause it and see how you did. Okay, so for number 1, you're tossing a penny and rolling a number cube. So the probability that you land on tails, so you're doing 2 actions, your first and your second. So the probability that you land on tails is 1/2. And then the probability that you land on 3 on your number cube is 1/6. There's nothing to cross cancel, so your probability is 1/12. For number 2, the probability that you land on your, your first thing is heads, so that probability is 1/2. And then the second thing is getting odd. So on a number cube, half of the numbers are odd. So 3 out of 6 are odd, or I'm just going to write it right now as 1/2 so I don't have to reduce later. And then when you multiply, you get 1/4. And then lastly, number 3, you're choosing cards and you're not replacing them. So that means once you take it out, you're not putting it back. And you want the probability of 2 even numbers. So we have our first pick and our second pick. So when you first go to pick, the even numbers available are 6 and 8. So you have 2 out of 5. So that's the probability that your first pick will be an even number. So you're going to assume that your first pick was an even number. So you're going to take it out. That means there's only 1 even number left. And there's not 5 cards now, there's only 4 cards. I'm going to cross cancel the 2 and the 4. There's nothing else I can cross cancel, so then you end up with 1/10, and this is your answer for number 3.